Today we're going to talk about how to verify trig identities. So we're going to use the fundamental identities to prove that one thing is equal to another. And I've listed some strategies here. You may want to write these down and have them in front of you as you do the problems. So in case you get stuck, you've got something to refer to. To go through them quickly, one thing that can sometimes work is to write all of your trig functions in terms of sine or cos and or cosine. Use your fundamental identities, right? Your quotient identities, Pythagorean identities, reciprocal identities, everything that you looked at in the previous video you want to have access to. And then we can always do a little algebra, like we may need to factor or add or use a conjugate once in a while. But what you always need to do is something. You can't just kind of sit and stare at the problem and hope that something will occur to you. And even if you make a bad decision and kind of go down a dead end somewhere, that can actually give you a little bit of insight into what you need to do in order to finish your proof. Now here's our first example problem. All the examples I'm doing are in our textbook, so if you wanted to see them written out, they're right there for you in our 5th chapter. And what I'm going to do is just show you one example of a proof. There are variations, so if you do something slightly different, that's okay, but we should end up in the same spot. So our job here is to show that this expression is equal to that expression. And one thing you want to do is work with the more complicated side, which seems to be the left side over here. So, and remember, we're only working one side at a time. So this side here, I'm kind of looking at this secant squared, thinking that secant squared can be written as tan squared plus 1. And then we'll still have this minus 1 after that. That's one of our Pythagorean identities. Now notice up here that those ones cancel and we end up with a simpler expression. Tan squared over secant squared must be equal to sine squared. Now there are a few different directions we can go from here. I think I'd like to use my quotient identity, though I'd rather use it correctly. Let's try that again. Tangent is sine squared over cos squared. And secant is 1 over cos. Now notice here we've got a fraction with the denominator of cosine squared and a fraction with the denominator of cosine squared, which means those can cancel. And look at that. On the left, all we're left with is sine squared theta, and that's equal to sine squared theta. So we're done. Once we get one side being equal to the other, make sure that you show that step. Notice how we're rewriting the untouched side with each step, so be sure that you do that also. And you're working vertically, okay? You don't want to do this work horizontally, each step vertical. Here's another example where the left side seems to be a little more complicated than the right. And on the left side, I'm looking at 2 fractions. And maybe we can add those together, but first we're going to need a common denominator. So the denominator would be 1 minus sine alpha, 1 plus sine alpha, and we'll need to multiply the numerators also. So the first numerator would be 1 plus sine. Okay, so first step, all we did was add those 2 fractions together. What's really nice about that is that those signs cancel out. And we end up with 2 in the numerator, which is a good thing because we've got a 2 over there. And how about we distribute that denominator? We're going to have 1 minus sine alpha plus sine alpha minus sine squared alpha Again, those signs will cancel, and it looks like we're getting closer here. 1 minus sine squared, we can rewrite that. 1 minus sine squared is cos squared. That's one of your Pythagorean identities. And now we can use a reciprocal identity. We've got 1 over cos squared over here, so we can move that to the numerator, get 2 secant squared equals 2 secant squared. Okay, here we've got another one where it looks like the left side is more complicated. And there are a few things that we can do. We could, we could distribute everything on the left, but I'm looking at that tan squared plus 1, and that's reminding me of secant squared. So I'm going to substitute that. And then cos squared plus 1, cos squared minus 1. I think I'm also going to use a Pythagorean identity for the cos squared. Cos squared is 1 minus sine squared, and then we still have the minus 1. Okay, next. These ones cancel. So now we've got secant squared times negative sine squared equals negative tan. Okay. Getting a little closer. Secant squared is 1 over cos squared. And if we multiplied those together, we get this. And our quotient identity says that this is equal to tan. And we're done. Once again, notice that the work is vertical. We're only working one side, and that on the other side we continue to write what we're trying to prove. So here's one where it's not really clear which side is more complicated. But I'm going to go with the left again, because I can do something like this. I can say tangent is sine over cos, and cotan is cos over sine. Now, if we combine those two fractions, the denominator would be cos times sine. So the numerators would be sine squared, and the second numerator would be cos squared. And now our new numerator right here is one of the Pythagorean identities. We know that that is equal to 1. And we're one step away. 1 over cos is cosecant, and 1 over sine, well, that isn't right. 1 over cos is secant. Let's try that again. And 1 over sine is cosecant. And there we go. That was a nice little one. Okay, this last one, we could work the left side again, just like the previous problem, but I want to show you something with the right side that sometimes comes in handy. Here, it would be really nice if this was a sine squared, because then we'd have a Pythagorean identity. In order to make that so, we can multiply by the conjugate. So left side is the same. Right side becomes cos times 1 plus sine over, we're going to distribute the denominator. We'll have 1. Now I'm going to skip a little step here because this is going to be sine x minus sine x. That's going to cancel. So negative sine times sine would be negative sine squared. Okay, now We've got that Pythagorean identity in the denominator. So we can write 1 minus sine squared as cos squared, which is really nice because then we can cancel that cosine with one of these. And we've got secant plus tan is 1 plus sine x over cos x. Okay, almost to the end here. We can write the right side as 1 over cos plus sine over cos, and look what we have. Using first the reciprocal identity, that'll be secant, then a quotient identity, that will be tangent. Now just keep in mind as you're doing these that there isn't one single way to verify your identities. So somebody might work the right side here using the conjugate. Somebody might work the left side, use the quotient and reciprocal identities and combine fractions. It really is up to you. There's almost no going wrong as long as you're correctly using your algebra and your identities.